Good morning. Friday morning after a long week. Thanks for coming. We're going to take a few minutes this morning and look at another way of putting it all together. If you were at the last session in this room, you saw end-to-end with the file server, storage spaces, across the network, Hyper-V, continuous availability, all of that working together. In this session, we're going to talk a little bit about the packaging and how you deliver some of that capability to customers. So we're going to talk specifically about NAS appliances, including why NAS appliances make sense. So let's get started. The audience for this is largely about people who package these together. We're going to talk about some of the software and customization for that. But it's about how do you deliver this product out to customers. The little secret that wasn't in the agenda is that with a couple of exceptions, once you put this together as a hardware system to make a file server appliance device, that same hardware makes a great Hyper-V appliance device or SQL Server appliance device as well. So there's multiple ways to use this, but we're going to focus mostly on the NAS file server appliance. So we'll talk a little bit about the Windows capabilities and then what that experience looks like. So if you've been following the continuous availability set of sessions at the conference, we're at the end. We've covered a lot of sessions, a lot of material in the sessions. It's important to note that these build on each other. So if you've missed any of the sessions on this slide, we're not going to cover all of the details that were covered in those. So here's a pointer back to some of the videos that you may want to watch if you haven't seen them in the sessions. Another piece of recap, and we're not going to talk about all of the details here, but I wanted to pull it all together and put it on one slide. Here's some of the things that are new in the file server for Windows Server 8. We have lots of changes in the storage, from storage spaces to the kind of scalability of volumes, the improvements in check disk, data deduplication, continuous availability in the file server, improvements in clustering, remote VSS backup, networking advancements, flexible file access, and that was another track. There's pointers at the end of this deck to the sessions around that as well, and some more about management. So, why talk about NAS appliances? Well, the simple answer is customers like them. The market data that we've looked at tells us that while file servers as a format is continuing to sell well, its relative numbers in terms of units have been declining when the economy was going down or growing slowly, much more slowly than the NAS appliance units, which have been on a fairly healthy track. So customers like it for a number of reasons. It's easier to deploy, it's easier to manage, it's a single-purpose device, and it's a way to deploy storage that supports virtualization in private cloud by being able to give a flexible access to storage, as Jose demonstrated in the demo in the last session. But there's another reason that NAS appliances are important, and they'll be important going forward, which is that the hardware that it takes to deliver the kind of performance that you saw, the 2.5 gigabytes per second kind of performance, requires some engineering on the hardware side. It's an end-to-end performance analysis, and we'll talk a little bit more about that. So putting these packages together, it doesn't happen with, no matter how good our software is, with taking a CD of Windows Server 8 and installing it on some server that you found under a desk someplace. It really takes some conscious planning to get the kind of performance that the software is capable of doing and what customers want in data center deployments. So we'll talk a little bit about that as well. So as we looked at the requirements for what we wanted to deliver in Windows 8, we started with this fundamental concept that you've been hearing over and over if you've been in the track that was on the previous slide. Continuous availability. Continuous availability has a couple of important elements. One is it's about software and hardware working together. You can't get continuous availability with just hardware. You can't get continuous availability with just software. You have to have them both, and they have to be working together to be designed to deliver the kind of continuous availability that customers expect. The second thing that's important on this definition is the primary objective has to be don't lose the data. Whatever you do, whatever time it takes to fail over, whatever availability that you have, doesn't count if you lose the data in the process. And then this concept of transparent failover, of making it possible for the user, whether it's a human user or an application user, to not see a blackout, not see a failure of the service that's being provided. So, what are the key requirements for a NAS appliance? In the marketplace, we're seeing that NAS appliances require multi-use capabilities. That multi-use has two dimensions, we believe. One is about heterogeneous environments in terms of the software stacks, Windows and Unix, file and block. Those have become the customer expectations minimum bar for NAS appliances. And it also applies across workloads, client workloads where you put a bunch of user folders and information worker documents, and as we've introduced the capabilities of Windows Server 8, server application workloads. The next thing, and I mentioned this earlier, is the hardware engineering. We're going to focus on two aspects of that. One is designing for end-to-end storage performance, and the other is designing for continuous availability. What does that actually mean? And the third part is around the appliance experience. Appliance experience in terms of the packaging, how you put it all together, and an appliance experience in terms of how the customer interacts with it, how they set it up and how they manage it. So we'll address 5 points here: the heterogeneous access, designing for storage performance, designing for availability, packaging, and configuration. So in the heterogeneous world, we haven't really talked about these in other sessions, so I wanted to call it out specifically. We believe in heterogeneous environments. We're in the business, in the file server business, file server team that I work in. We understand that customers don't have just Windows. They have lots of things in their data centers. So we took the concept of continuous availability and applied that across the different ways that customers access their data. We did continuous availability for iSCSI Target in Windows Server 8. The NFS v3 server shipped previously, but now in Windows Server 8, it works with continuous availability. And then another aspect that we haven't talked about so far in this conference is Windows Server 8 will have an NFS v4.1 server in the box. All right, so heterogeneous. Now, end-to-end storage performance. So there's more details, and this could be a whole session in itself. I refer you back to some of the comments and the discussion in the previous previous sessions where we talked about designing for scalability and performance for continuous availability. But I wanted to put out a couple of examples of what these systems might look like and what the bottlenecks might be. People tend to think about servers as mostly processing and CPU. And if you think about a server that the workload is running on the server, that's primarily the way that it gets experienced. It gets data from disk of some sort, storage of some sort, does the processing locally, and it's only the results that go out across the network. If you're building a storage device or a NAS appliance, the paradigm is a little bit different. You have to serve up data. That's the whole purpose in life. So you have to be able to get that data from the disk platters up into the system and out the other end through the network to the clients that are asking for the data. So you have to think about how that stacks up on an end-to-end basis. And a couple of examples that I put on the slide here. So if you look at example number 1, kind of a typical approach might be, well, I've heard about continuous availability, heard about taking advantage of multiple NICs, so I'm going to put a couple of 1 gig NICs on this system. And it's a relatively small appliance, so it's got a dozen disks in the back. So what I did was calculate the throughput at various points through the system here and turned them all into gigabytes per second. So you've got 12 disks, 7,200 RPM disks. That's going to give you about 1.5 gigabytes per second. Calculate the SAS connections, calculate PCIe. Well, when you look at gigabytes per second on the network, you see the whole system is going to be throttled by the amount of data that you can push out across the network. 0.23 gigabytes per second. So that system, it might be exactly the right system to ship. The point of this slide isn't that you have to do it any particular way. The point is to do the engineering to make sure that you understand what it is that you're delivering and whether you've designed the bottlenecks. There's always going to be a bottleneck across one of these, some factor in your system. But be conscious of the bottlenecks. We've seen OEMs that have built systems with our software, and they haven't gotten the kind of performance end-to-end that they expected. And it's usually around some form of bottleneck, including both the throughput here, or the file server tends to need sometimes more RAM than people expect. It's generally not CPU bound. You saw from some of the demos, we can pump out a lot of data with relatively low CPU, but it does need memory for open handles, for instance, and that varies by workload. But identify the bottlenecks, balance this stuff across the various places where the data has to pass. The second example on this slide said, okay, if you increase the network up to 10 gigabit Ethernet NICs, you're going to reduce that bottleneck on the network side, but now, unless you pay attention to the PCIe data path throughput, you'll have a bottleneck there. And you can do those calculations. They're relatively straightforward. The point is, do the calculations, get the results that you want. So, designing for continuous availability. We mentioned transparent failover in the definition of continuous availability. I wanted to make clear what we mean when we talk about transparent failover. Transparent failover to us means that from the perspective of the user, there's no errors visible. you don't lose data, and you perform well at scale. So how do you design for that? Here's what we think it effectively means. Some of these are pretty much essential. If you have a system that doesn't have redundancy in this data storage on the disks, and you lose a disk, you're going to lose data. That violates the fundamental principle. You can't lose data. So whether it's a single node or a multiple node system, you have to deal with the data redundancy. Some of that's available in Windows with the capabilities of storage spaces, or it might be taking advantage of clustered PCI RAID or external arrays. If your system fails, though, then the service can't be continuously available. So we're pushing to move the expectations of customers from single node systems to multi-node systems. And we'll show an example here in a minute. But that's the fundamental next step, is make your systems continuously available by using clustering. And you need to have then transparent failover between the nodes. The other aspects on here, the ones marked with X's, those are things that you can do. There'll be a range of solutions, and depending on the price point of the package that you deliver, you're going to want to implement multiple network connections, multiple storage connections, and redundant hardware components, including things like power supply. So, packaging. We think that one of the ways in which customers are going to prefer to experience this, and that actually opens up a substantial market for those of you in the room who build these kinds of systems, is integrating the packaging of how you deliver the hardware and software for NAS appliances. So the picture on the screen is an example. It's a prototype that we've worked with an ODM to put together. If you were at Thomas's overview yesterday, you saw some of the physical hardware, and we have examples of this in the bit bar and the expo areas downstairs. So come by and take a look. So if you're going to build a cluster in the box, here's an example of the logical diagram for one of these systems. It's fairly straightforward. Think about the redundancy of the components. Think about the interconnects and the data paths that you need to have to make that work and to make the system be able to fail over. So from between the CPUs, you need to have an interconnect where the networking can talk between the two systems. From each CPU, you need to be able to see the data. It has to be connected to both systems. And that may be through expanders, it may be through SAS networking. There's various ways to do that. But think about how the data flows and what happens when any individual component might fail. A couple of other things that aren't necessarily obvious that we're seeing as we try to design these systems is you have heard about a lot of different networking options this week. Networking with 10 gig E, networking with the InfiniBand, different formats of InfiniBand. Customers are going to have their expectations of what they're using for networking in their data center. So one of the recommendations here is to make sure that you give that kind of flexibility. Think about how customers can plug in the networking that works for their system. And then think about the expandability. When you build this kind of box, capacity is the one thing that you can run out of quite easily, even if the actual throughput stays the same. You may have more and more data on that system. So give expandability. Look at the ports for external expansion. And finally, if you're taking these to a broader market, especially the low-end departmental or branch office scenarios. Think about the power supply requirements. Can you plug it into a power outlet in a standard office? Can you tolerate the noise, the volume of the operation of the machine? So with that, I want to turn it over to looking at the experience of how customers engage in the deployment and setup of this. And Christian Teodorescu is going to come talk about that as well as give you a demo.
Thank you, Jim. Hello, everyone. So today I'm going to focus on the out-of-box experience for the NAS appliances built using Windows 8. And I have a couple of slides trying to explain what we were trying to achieve. But most importantly, I'm going to demonstrate the out-of-box experience, complete with the opportunities for our OEM partners to actually customize and extend the out-of-box experience for their benefit and for their customers' benefit. So with that, okay. Let's talk about what we were trying to achieve first. We all know that customers expect that a dedicated appliance should be much simpler to configure than your garden variety server solution. So before we embarked on this journey, we came up with a very simple vision statement, which you can see at the top of the slide there. So first of all, we want this experience to be fast. It shouldn't take, in our opinion, more than, let's say, 15 minutes, give or take, depending on the hardware, of configuration time between the moment when the appliance is powered on and the moment when the appliance is ready to share the first files. Now, you can't achieve that if the experience is not simple. We don't want the user to go to, like, I don't know, tens of pages of deployment guides and try to figure out what needs to be done. So we invested a lot in doing things like minimizing the number of configuration steps, providing the very good defaults for the configuration settings, and most importantly, providing a guided workflow through these steps in order to eliminate the guesswork for the user. Now, this led us to the concept of a single console. We don't want the user to have to connect to all the nodes of the cluster, and on each one of them, do some repetitive steps that can be not just boring, but also error-prone. What we want is the user to connect to only one node of the cluster, run a single pane of glass application that guides the user through those steps, and under the covers, apply the configuration changes that the user selected on all the nodes of the appliance. And finally, we recognize that the OEMs are special. They have special appliances, they have special hardware, they have special software. All that requires some special configuration. There is a need for branding. There is a need for some other type of differentiation. So because of that, it's super important for us to provide a customization framework such that our partners can actually extend the capabilities of the OEM and differentiate it. All right, before I get into the demo, I just want to give you a very high-level overview of the experience for the customer, which is what you see at the bottom of the slide here. So the customer receives the package with the appliance inside, takes the appliance out of the package, installs it in the back office or in the data center, wherever. Then goes and plugs in the network cables. And in our opinion, that should be as simple as, hey, customer, please plug in the red cable into the red adapter port at the back, the blue cable into the blue adapter port in the back. It should be as simple as that. After that, the customer powers on the appliance and is greeted by the Windows welcome dialog, which is what you all know. The user gets to pick the language, accept the EULA, at which point we display that single pane of glass, which we call the initial configuration tasks application, which guides the user through the rest of the process. At the end of that, in about 15 minutes, the appliance is configured, and the user can start sharing files from that appliance. Very simple. Now, obviously, there is a lot of work that needs to happen in the OEM factory in order to provide that simple experience for the user. The most important step there is obviously to prepare that master image that needs to apply on the NAS appliances. I'm going to talk about that in more detail later, but one of the important steps in that process is the actual customization of the out-of-box experience. Okay, with that, I'm going to proceed to the demo. Let me just do a quick check here. Okay. All right. So I'm going to demonstrate the out-of-box experience of a 2-node cluster in a box appliance. I'm going to demonstrate only the initial configuration task application because, quite honestly, the Windows Welcome dialog is neither new nor terribly interesting. Now, I don't have a NAS appliance with me here. All I have is a pretty old laptop running Windows Server with Hyper-V. So I'm going to simulate the 2 nodes of the cluster using 2 VMs in Hyper-V. And actually, you can see them here. They are called Master 1 and Master 2. I have a third VM in the environment, which provides a domain controller, DNS server, DHCP, and most importantly, a nice SCSI target, which provides shared storage between the 2 nodes. So that's my simulated cluster in the box in Hyper-V. OK, let me show you the first node first. You can see that the first node is displaying the initial configuration tasks application. Here is where all the action is going to happen. There's nothing to be done on the second node. But because you guys are curious, I'm going to show you the second node as well. So as you can see, the second node, the only thing that it's doing is displaying a very nice warning message that tells the user to go to the first node to do the configuration from there. There's absolutely no reason to do anything on node number 2. So with that, let's go back to the first node. Now, quick orientation through the ICT application. You can see here a bunch of sections. There are about 3 in this section of the screen. They are called task groups. Each task group has 1 or multiple tasks. Each one comes with a command that you can click on. And it displays a bunch of property value pairs, which describe the status of the appliance with respect to that task at the moment of the refresh. All right, so with that, let's go to the experience. The first thing to note here in the first section is that the first node has already detected and connected the second node. That is done through a magic process called network discovery, where the first node discovers who is attached to the crossover network link between the 2 nodes. Somewhere in the appliance, there is a crossover link between the 2 nodes. And you can actually see all the network adapters of the 2 nodes in the second section here. And one important thing to note there is that they already come pre-configured with some very user-friendly, self-explanatory names that tell you exactly what those NICs are doing. One is crossover, the other one is public on each one of the nodes, complete with color coding, red and green, that pretty much helps the customer connect the cables properly in the back of the appliance. So this is how we totally simplify that network configuration there. There are some defaults here. You can see that DHCP is basically we're doing dynamic IP addresses by default. Now the user can actually go and and change the network configuration using the usual Windows applet. Now, this comes particularly handy if, for instance, the user wants to use static IP addresses instead of DHCP. No need for that in my environment because I have DHCP. So I'm going to skip the network configuration. You can do the same thing on the second node if you want. Let's go to the next step. The next step is set time zone. Well, the default time zone is Pacific time. I'm from Seattle. We are in Anaheim. Pacific time works great for us. I'm going to go with the default again. Here's the first step where we actually need to do some more work. This is about providing the cluster name and joining a domain. This is done through a wizard. What you see here are some pre-validation steps that the ICT application does. And here we go. The name of my domain is demo. I need to provide the credential of a domain administrator. OK, now it verifies that the domain and the user actually exist. All right, let's say I want to provision this file server for the sales department of our organization. So I'm going to call it sales_fs. Actually, it's not a valid format, so I'm going to pick something else. Salesfs25, about this one. OK, so you see that the nodes are named based on the name of the cluster. By default, you can change that if you want. Here, we're adding the domain administrator to the local administrative groups of both nodes. And finally, we need to provide a local admin password, which is going to be applied to both nodes in the appliance. There's absolutely no need to have differences between them in terms of passwords and all that. And with that, we got to the end of the wizard. As in any wizard, here is the place where all the configuration changes are applied. You can see that the ICT app actually acts as an orchestrator, which applies the changes to both nodes kind of in lockstep. This goes into that principle of not having to connect to two nodes and do the same operations on each one of them. OK, almost there. So we're done with this. OK, so we just joined a domain. So there's no way to continue with other operations without having to reboot the system first. While we cannot avoid that, what we can do is to actually make that process as seamless as possible, meaning that the ICT, again, acts as an orchestrator who restarts both nodes in parallel. And when the nodes come back up, the first node is going to reload the ICT application. And then the user will be able to restart from the next step of configuration immediately after join domain. Now, my demo environment is, again, very slow. It doesn't quite make justice to the Woobi. So it's actually going to take a few minutes to reboot. I don't want you guys to stare at that for a few minutes. So in order to avoid that, I'm going to play a little bit of Hyper-V trickery, which means I'm going to fast forward the VMs to snapshots that I took on a previous run of the demo at the point where the machines came back from the reboot. OK? All right, so I applied the snapshot on the second node. Let me do that on the first node as well. All right, the second node is almost back. Let's take a look at it. You can see that the second node is now sitting at the logon screen. Again, this is just for your information. There's absolutely no need for the user to do anything on the second node. The second node is going to stay like this until the end of the demo. Let's see how the first node is doing. OK. Looks like the first node is up and running. And you can see that it reloaded the ICT application. Now, there is one more step I need to do before I'm back in the business. Because this was just recovered from a snapshot, the internal connections between the first node and the second node and with the domain controller are kind of stale. They are from a run from yesterday. So I need to run this refresh in order to recreate those connections. And you can see that the refresh is happening here at the back. It takes a few tens of seconds, but believe me, all this is taking kind of half of the time of the reboot on this slow laptop. So bear with me for a while. OK, still waiting. OK, I feel we're getting close. All right, so let me close this. And with that, we're back in business. We can resume the configuration. So the last step was join domain. The next step is enable automatic updates and CEIP. There are cases where the administrators don't want to do that on their super critical appliances. They want to control that process better. So I'll go with the default of not configuring automatic updates. So the next section is a very important one. It's all about provisioning the storage that comes with the application. In my example, this particular appliance has come with a bunch of disks that are not partitioned, are not formatted. Now, I want to create a volume on those disks where I want to store all the shares for the sales department. And also, this being a clustered appliance, I want to also have a witness disk for the cluster. So at the minimum, I want to create a couple of volumes on this appliance. The way to do that is to new volume wizard, which you can see here. Now, this volume wizard offers two ways of creating volumes. The option at the bottom here, which is actually what I'm going to use for this demo, is to create a simple volume on one of the shared disks of the appliance. Remember that the disk needs to be shared between the two nodes in order to get to a highly available solution. Now, there is a second option, which is here in the middle and is disabled right now, which allows the user to create a virtual disk that can be fault tolerant, for instance, in a pre-configured storage pool existing on the appliance. That can come either from storage spaces, which is the new storage virtualization technology that you guys have heard about here, that we're going to ship in Windows 8. Or it can come from a PCI RAID card or some other form of RAID controller that the appliance might have. I'm going to go with the simple solution here. So I pick the first disk. I'm going to create a volume with dry letter E. I'm going to call it shares, because here is where I'm going to store my shares. And with that, this is the end of the wizard. Again, as in any wizard, here is the place where we're actually doing the work. Now, I have to be completely honest. And again, we're still pre-beta. I'm not that happy, for instance, with the amount of information we're displaying on the screen. Some of that information is not quite relevant for the end user. it makes a lot of sense from the perspective of a PowerShell script that has to go through all those steps. So almost there, we're waiting for the volume to be formatted. Okay, close this one. We suppress this dialog. We're going to suppress it automatically in beta. And then let's go and create the second volume. We're going to use the same wizard. Okay. We're going to pick the simple option again. There is another disk which is not formatted yet. This time around, we'll go with F, and we call this guy witness. Okay. And we're going to go again through the same steps. And the other investment that we're already doing for beta is obviously to make this phase a little bit faster. We already made some good progress on that on some private builds back in London. Okay. Again, waiting for the formatting. All right. Suppress that, and then here we go. Network is configured, storage is configured. There is only one step left in the process, which is create the cluster. All right, that's done through another wizard, and there are some pre-validation steps that we do. Now, some of you may ask, OK, so why do you need to create the cluster in the out-of-box experience? Why doesn't the cluster come pre-configured from with the appliance from the OEM factory? Well, unfortunately, it turns out that in order to create the cluster, you need to have the two nodes already joined to a domain. And the domain is very user-specific. It's not something that the OEM can guess in the factory. So because of that reason, we have no choice but to create the cluster here at the end of the out-of-box experience. But having said that, this is the next best thing that we can do to speed up the configuration. OK, so here you see what the ICT is doing in terms of validation before actually displaying the wizard. The steps are pretty self-explanatory there. So it's going to take one more second. OK. So here's the wizard. And now we get to the actual, real, very comprehensive validation that we need to do for the environment before creating the cluster. Those of you who are familiar with the failover cluster feature in Windows know that it's super recommended to run this comprehensive validation before creating the cluster, because what you want to avoid is that after you create the cluster, and let's say a month later you have a failure in the system, you really, really, really want the cluster to fail over correctly. So it's a very good idea to have the failover cluster perform a bunch of tests on the storage, on the network configuration of the two nodes now, before creating the cluster, in order to avoid those very nasty surprises down the road. Now, again, this is a slow demo environment, and it's going to take about 3-4 minutes to do that validation here. I can tell you it's much faster in reality. So what I'm going to do, I'm going to switch to another slide here. So this is about what are the kind of steps that the OEM needs to do in the factory in order to prepare that master NAS appliance for the image for the appliances. First of all, they should start with the master machine, hopefully having the same hardware as the appliance is to be shipped. And then they need to install Windows Server, install the drivers specific to the hardware, install the Windows roles, and hopefully file services is one of the roles, because otherwise you don't get much of a NAS appliance. And then there are a bunch of exotic registry keys that you might want to set in order to optimize the file server. I don't know, maybe you want to enable remote management of the appliance and so on and so forth. The second step there is to provide a configuration file in which you need to list all the NICs present on all the nodes, complete with their PCI bus identifiers and user-friendly names that you want to be displayed to the user. This is how you can help us, help the customer find those NICs and do the right cabling of the networking. Then you have to provide a way to allow the user to do management of the storage technology included with the appliance. If your storage technology of choice is storage spaces, then you don't need to do anything. Our Windows management tools will do that seamlessly for you. If we have PCI RAID or some other RAID controller, well, if those support SMIS or the new storage management API that we ship in Windows 8, you need to install a provider for that. And then again, the Windows management tools will take care of that. If none of the above apply, then, then you need to install your proprietary server manager UI. And then feel free to install some other software related to backup, security, whatever you feel is necessary for your appliance. Then you have the all-important step of customizing the UBI. And I promise you that I'm going to get there in like 5 minutes. And there is a final step, which is to run sysprep for the image and to configure the unattended install. So with that, the image is sealed and can be applied to all the appliances that you're going to ship to the customer. So let me switch back to the demo. OK? So we just finished the cluster validation. You can see here that it has completed with a warning. But that means it was successful, actually. The cluster is conditionally approved. There is a very comprehensive cluster validation report here. Ignore this one. Which is very easy to navigate, actually. You can see that the warning is in the network section. And it's actually related to IP addresses. Let's scroll down. You can see some stuff in yellow. Those are the warnings. They are not terribly interesting for my environment here. So with that, sorry, let me go back. OK. So with that, I'm going to go back to the wizard. So this was 25. OK. Now, this wizard doesn't limit itself to just creating the cluster. Since this is supposed to be a NAS appliance, it also offers by default to create a highly available file server instance on the cluster. One can go and disable that using this checkbox, but we expect that most customers are going to take the offer, so I'm going to take it as well. And with that, we got to the end of the wizard. Again, all the configuration operations are applied here. There are only two here. One is the creation of the cluster. The other one is the creation of the highly available file server. Now, from my experience in previous runs, again, in this relatively slow demo environment, it takes about a few tens of seconds each one. So again, we need to be a little bit patient. Okay, the first one just succeeded. Obviously, these are operations that require some complicated dance between the two nodes. This is why they usually take a little bit more time. And we should be pretty close now. Right, getting there. Almost there. All right, success. So with that, we close the wizard. We go back to the ICT. We look at the bottom, cluster status is created. And there's nothing else left in the ICT. So all I have to do is, please don't show this window again. Close. And at this point, the appliance is ready for file sharing. It's as simple as that. Now, you may ask, OK, how do we know that you really created a cluster? Maybe you cheated on us. OK, well, let's open the failover cluster manager snapping, this is the management tool of choice for ongoing management of a cluster. You can see that a cluster with that name has indeed been created. You can see that the cluster has 2 nodes with those names. You can see that there is a file server instance running on it, which now is highly available and can fail over between the nodes. It's up and running, status green. If you click on shares, you can see there is already a default administrative share on volume E, which is the volume that I'm going to use to create shares. And finally, I'm going to show you that there is here an option to add some more shares if you want to. And you have the same option in the new server manager UI that we're going to ship in Windows 8, which has a very nice section for the file server administrative center that you're going to find there. It's a single pane of glass for ongoing management of a file server appliance over there, which I'm not going to demonstrate today because we don't have that much time. So with that, this concludes the first part of my demo. How are you doing on time? In the second part, probably you have been waiting for that to happen. I'm going to demonstrate the customization of the ICT application. Now, that's so simple to do that I don't really need a specialized dev environment. I can do it on the appliance itself. As you can see, I'm still running on the first node of the appliance. So all the interesting files are in this directory over here. And the most interesting file is called oemubi.xml. OK. All right, let me navigate to some more interesting. All right, let's stay here. So let me give you a little bit of background first. The ICT application is based on WPF, which means that the layout of the UI is controlled by this XML file over here. So quick orientation, for every task group, you can find a section. You can see the title here, update this server. And then within a task group, you can see a subsection for each one of the tasks of the task group. Each one comes with a title, an image, which is a file, a command, which in this case is an executable. You can run a local executable. You can run Internet Explorer pointing to a website. You can run a PowerShell script, whatever you want to do. And then there is a property. This one is called updates. And it displays the value taken from a global variable called g underscore something. Now, it's very easy to actually copy-paste tasks and task groups and just change titles, icons, and variables. And you can get up and running and customize the UBI even without reading the deployment guide. Although we will obviously provide a deployment guide for this one. So what I did in my copious spare time, just a second, I created a customized version of that XML file named custom underscore. Let me show you the differences between these two files, and they are not that big. I'm going to use this tool called WinDiff that displays the differences. You can see that the first couple of differences are just, I changed a couple of icons, the icon of the application. The next one, I added a new task called register. This is for registering the application, the appliance. The command here is Internet Explorer running a local HTML page, which is very cheesy. You're going to see it, but that's not the point of the demo. And then I have a property called registered, which should display the status of the appliance related to the registration. And it displays the value of a global variable called g underscore register. And with that, I created also a task group called Super NAS Information Links, which has two tasks. One is linked to order additional storage. This is just an example. Another one is linked to the storage configuration manuals if your storage is so complicated that the user really needs to read something. These are just theoretical examples. So these are the changes in the custom XML. Now I'm very confident I'm going to delete the old one, the original. And I'm going to rename the customized one to the original. So the ICT will pick this one now. Now, remember that we just referenced a new variable called g underscore registered. So we need to somehow at least initialize that variable somewhere. So the file where all the variables are initialized and set during refreshes is this one, oemubi.ps1. So here is the file. Here I need to look for a function called initialize global variables. Oh, sorry. Did I? OK. Yeah, you're right. Thank you very much. So PS1, much better. So is global. OK. So here is the function where all the variables are initialized at the beginning of the application. So all I'm going to do is I'm going to add here a line that says global g registered equal false. Now, you can also add a function that is called during a refresh, which will refresh that value based, which is particularly useful after you actually register the appliance. But I'm going to save this one here. OK? And the last thing I want to show you is that obviously the ICT is localized, and it can be localized on a very, very large variety of languages. The English localization of all the strings is in this file here, .en.resx. And I'm just going to do a very simple thing to it. If you go to the bottom, just a second. Where is it? Here. The last element here is the actual title of the ICT application window. It has a original value of initial configuration tasks, which is the original name. So I'm going to replace that by Super NAS setup. And now I have a new title. And with that, I save. All right, so we're ready. Let's see the fruits of our labor. So let's run again the ICT. And as you can imagine, the name is oemubi.exe. Let's see. All right. So we can already see that we have a new title, Super NAS Setup. We have a new icon, Super NAS. Let's say it's a green OEM, so it picked a nice logo of image of planet Earth. It has the same icon in the Windows taskbar. Now if you go here, pretty much is all the same until this new task, register. The status is false. You can use yes or no, which is probably more useful for the customer. And then if you click on register, now you can see my great work of art, the HTML page which does nothing. But you can imagine here having a link to your own website that allows for registration. I'm going to close this one. Oh, sorry, I went to the Hyper-V Manager. All right, so I'm going to close this one here. And let's go down. Oh, there's a new task group, Super NAS Information Links, which does 2 tasks, order additional storage and storage configuration manuals, the same kind of, this can be a link to your help, and you can click on that. And with that, these were the changes that we applied to the OEM movie. One more piece of information. This is not limited to just adding tasks and task groups. You can also delete them. You can also edit them. You can also change the order of tasks and task groups with some very, very small limitations. And you can play with it, and hopefully you guys are going to do a much better job than what I did in my 5-minute customization. With that, the demo is done, and I'm going to hand it over to Jin for the final thoughts on this talk. Thank you, Jin.
Great. So we're running over on time. Not going to take much. I just wanted to click through here. Leave you with 2 thoughts. One is, NAS appliances are out there. Customers want them. Here's a few pointers on some of the things to think about of the advantages of using Windows as the basis for building your NAS server, some of the things that we can bring to increase the advantages of that and the attractiveness to your customers, as well as getting it to customers and to the market quickly. And finally, as I promised, pointers to some additional slides. The continuous availability platform talks, I'd encourage you to go look at any of those that you've missed. There's a section on file classification and dynamic access control. I mentioned a little bit earlier, there's 3 sessions that can talk about that. It's kind of a sleeper feature that we're delivering in Win 8. And then some other Windows Server 8 talks that are related to the technologies for making this all work. So thank you very much for your attention on a Friday morning. There's the links to feedback and questions. And we'll hang around for questions down in front afterwards. Thank you.